Chromatography is a way of separating the solutes or dissolved substances in a solution. You've probably carried out paper chromatography in school or college. The samples to be analysed are placed in a line above the solvent. As the solvent migrates up the paper, the substances in the spots separate due to differences in two things. Solubility in the solvent, so for example solubility in water, which of course is aqueous, or non-aqueous solvents like propanone, such as acetone. Remember, the more soluble substances travel further, so the type of solvent used is very important. The second thing is adsorption, not absorption. Adsorption is a measure of the amount of substance that binds or sticks to the surface of a solid support, which is paper in this example, or thin layer plate, TLC for short, which is used for preliminary analysis in forensic science. Yes, I know what you're thinking. What is a chromatogram? Well, a chromatogram is a solid surface upon which components are separated from their mixtures. In this chromatogram, comparing different inks, the unknown ink, U, is the same ink as B2, as it contains the same colours or dyes. Ink B is not a mixture because it only contains one colour. Ink B3 is a mixture containing three colours. One is the same as that in ink B. Sometimes the mixture you are separating is colourless, such as the mixture of amino acids. In this case, a locating agent, such as ninhydrin, is used to show the position of the dots. It's sprayed onto the paper and will react with the substances to show their location. A more accurate way to identify solutes dissolved in the mixtures is to find their RF value in a particular solvent. The retention factor is the distance moved by the spot divided by the distance moved by the solvent. Using this information, you can calculate the retention factor, or RF, for each substance using this formula. So for substance B, which has moved 50 centimetres from the origin, and the solvent has moved 60 centimetres from the origin, the RF value is 0.83. Now you have a go at calculating the retention factor, or RF value, of substance G, which has migrated up the paper 30 centimetres from the point of origin. Also remember that the solvent front is at 60 centimetres from the baseline in this case. Remember, the retention factor, or RF value, is calculated by dividing the distance travelled by the spot over the distance travelled by the solvent. So the distance moved by the spot from substance G is 30 centimetres. The distance moved by the solvent is 60 centimetres. 30 divided by 60 is 0.5.